Hello everyone, I am Dr. C. Ganesh, Associate Professor from the Department of Computer and Communication Engineering from Eshwar College of Engineering, Coimbatore. So we would like to have a discussion regarding the topic building smarter systems, IoT technologies, data insights, and future trends. I think all of you know the IoT has become a very important field nowadays. Many students they are doing the project regarding IoT. They are going to combine IoT with 5G and other technologies. So that is making the IoT is a very good for a lot of applications that we come across our daily lives. So in this lecture, we are going to see what are the basics about IoT, what is the history of IoT, the evolution of IoT, and also how we can use the IoT for applications and how we can develop the IoT in the future. That is the motive of this lecture. I would like to give the agenda of the presentation. First is IoT and its significance. Next is the evolution of IoT devices, IoT ecosystem and architecture, structured versus unstructured data, IoT data analytics. Then we are going to the big data, then SQL and NoSQL database, then role of machine learning, then tools and resources for IoT, application, challenges, and role of academia in IoT research. So these are the topics that we are going to cover in this lecture. So first I would like to start about the IoT. What is the IoT? IoT is the Internet of Things, Internet of Network of Physical Objects or things which are embedded with electronics, software, sensors, and network connectivity that will enable the objects to collect and exchange the data. So with the IoT, we can able to collect a lot of information. We can exchange the information and we can able to make some useful application based on the data that we have collected from the IoT sensors. Then it allows objects to be sensed and controlled remotely across the existing network infrastructure, creating opportunity for more direct integration between the physical world and computer-based systems. Thereby, we can able to improve efficiency, accuracy, and economic benefits. So we can able to transfer the data from one place to another place. We can set a remote location. From there, we can able to monitor the different parameters. Then we can give it to the machine learning algorithm that is going to give the prediction or it's going to give the classification result based on the application. So this is the basics of IoT. So it involves the collection of devices which are connected together that is going to perform some task and that will be very useful for different applications. That is IoT. In the right side of the PPT, you can able to see the picture of Kevin Ashton, who is the father of IoT. He is the person who has coined the term Internet of Things during his job at MIT at USA. As we discussed already in the previous slide, IoT is nothing but a collection of different devices like heart monitoring implants, biochip, transponders, electric lamps, then automobiles, DNA devices, everything. So these devices are used in IoT. These devices they collect the data from different environments, and this data can be used for some useful applications. Then these devices will collect the data and along with the latest technology like 5G, AI, and data science, we can make it for some useful applications. So we would like to discuss regarding the evolution of IoT devices, how the IoT came into existence. The first one is inception of IoT, pre-1990s. You can see the image of the first IoT devices, the connected devices, that is the Coca-Cola vending machine. So before the term IoT existed, early concepts of connected devices were explored. So different uh, systems or devices are connected together to form a system. Thereby, we can able to develop useful applications. The first example was in 1982. The researchers were working at the Carnegie Mellon University. They used the Coca-Cola vending machine that is connected with the ARPANET. So this is the first example of connected device. So before this, the people were using only a single device, but here they are going to connect the different devices with the centralized system. So this is the first example of connected device. So using this vending machine, we can able to get the bottles. We can check the drink availability of the Coca-Cola drinks, and we can able to know the temperature of the bottle. So this is the first example of connected devices. Then next we go for one more example, RFID. I think all of you know RFID means the radio frequency identification and detection that is used in many applications like toll gates, supermarkets, many places where we are improving the logistics or supply chain. So we are using the RFID not only in commercial application but also for the very high application involving this department defense or space exploration also. So RFID is used by Walmart and US Department of Defense in their activities. So RFID is a very important thing for IoT applications. The next one is the embedded systems and wireless connectivity. It was developed from 2010. This 10 years is the very important years for development of embedded systems and other devices. You might have seen the thermostat. I think in the right side of the PPT, you can able to see the thermostat image is given. Thereby, we can able to control the room temperature based on the needs of the user. So we can able to connect the Wi-Fi, Bluetooth, and other devices. That way, we can able to control the room temperature. The example that is given here is the Nest Learning Thermostat. It was developed in 2011. It is one of the first IoT products that could learn the user behavior and optimize the energy usage. Because nowadays we are moving towards the green environment where we need to reduce the resources usage. So this device will be very much helpful to reduce the energy usage because we can able to switch off the AC or some other device once the temperature is exceeded or set point is reached. So this device is very important to save the energy. The next one is the on seeing the picture you can able to understand this is the Amazon Echo. It is powered by Alexa. It allows the user to control the home appliances using the voice command. So we no need to have the physical connection. Just we need to control the device by giving the voice commands. This device is called as Amazon Echo. That is, it was developed in the year 2014, and Google Nest Hub made the voice controlled AI assistants mainstream. So we have a lot of devices coming daily. You can see in the Flipkart or Amazon, that is voice control device. Using voice commands, we can able to control the operation of the device. So we need to integrate the cloud also because we need to store a lot of data. So cloud can be used to store the data that will be providing the database support, and we can also use the other IoT devices. The next one is the edge computing. Edge computing and AI powered IoT from 2015 to 2020. Smart vehicles. So this edge computing is a very important technology that we are using in the smart vehicles where we need to take the decisions immediately. Suppose we don't have time to take the decisions. We can use edge computing because edge computing is very much fast compared to the cloud computing because in the cloud computing data goes to the cloud. It takes some time to store in the cloud. And from the cloud, the data has to be processed and the result has to come back to the end user place. It takes a lot of time. But the edge computing, on the other hand, it is nothing but the doing the processing at the place where the data is generated. That means it is going to reduce the time of data transmission and latency, etc. So it improves the speed and efficiency that makes the self-driving cars and real-time AI processing is possible. I think all of you know the Tesla's autopilot car that uses this edge computing to make the decisions at the very fast time. You can able to control the car with the help of the edge computing. In this application, we cannot use cloud computing because it takes a lot of time. So most of the real-time applications that is using the edge computing rather than cloud computing. The next one is the wearable devices like a bio IoT where we are using some devices that we are fitting in our human body that will be very helpful for measuring some parameters like our eyesight, our blood glucose level, or the heart rate, SpO2 level, etc. So these devices they are wearable devices that is fixed with the human body. These devices will be giving the various parameters like pressure, temperature, everything. So one of the latest devices, Mojo Vision's smart contact lens that is providing the health data real-time information based on the human eyes. It also uses the augmented reality technology that captures the information from the user eyes. So this kind of thing is being developed in the present generation where the IoT is developed at a very rapid rate starting from 1970 to 2024. So this is about the evolution of IoT devices. Then we move on to the IoT ecosystem. The ecosystem means we need to know what are the various parameters are present in the IoT. So if we want to develop the IoT system, we need to have the sensors. The sensors will collect real-time data like pressure sensor, temperature, humidity, moisture, etc. So these sensors directly get the data from the user from wearable device or some other device or something like that. Sometimes the sensor may be a very small sensor, sometimes it may be a very large one. That may be a wearable also. So we collect the data from the sensor. The data is transmitted to the communication and processing devices like a gateway. These devices will capture the data and the data is sent to the cloud where the data is being stored, and here we can also do some processing using the cloud technology, that is real-time processing. Then we go for the data archive. Archive means where we can able to store the data for the future purpose. Then we can do for the presentation or recommendation or visualization after applying the machine learning or deep learning algorithms on the data that is stored in the cloud. So this is the overall ecosystem of the IoT, where we start with the sensor, collect the data, then by using communication device, we store the data in the cloud, then we do the processing using the machine learning or deep learning algorithms or other algorithms. Then we show the result by creating a chart like visual presentation or recommendation. This is the IoT ecosystem. Then we could see the different components which are present in IoT ecosystem. First one, sensors and actuators. So without sensors, we cannot able to collect the data. The sensor means the device that is used to collect some data. It's very important to use the sensor because we collect the real-time data from the different environments. Then edge devices like gateways or some other computer systems. These devices are capable of capturing the data from the sensor and they send the data to the processing device. In communication protocols, we use some protocols like Wi-Fi, Bluetooth, Zigbee, LoRa or some other protocols. That is very much important for communication of data from one place to another place. Nowadays we go for the LoRa and 5G. That will be very helpful for transmitting the data at very high speed communication. Then cloud platforms. So we have some cloud computing for data storage. Suppose I want to store a large amount of data that cannot be stored in the normal computer. So we need a large processing power. So we go for the cloud computing for storing the data. So we have centralized infrastructure for storing the data and processing and also for analysis. So it provides the scalability. That means in the future, even if you want to store more amount of data, we can able to store in the cloud computing. We can able to purchase the data by paying some money to AWS or Google Cloud, etc. So these are the main things that present in the IoT ecosystem. And we go for network infrastructure. We have the 5G and 6G networks, 4G, etc. These are very much important for connecting the various devices in the ecosystem. Then we go for data analytics tools. We have the machine learning models where we can do some prediction or we can do some classification tasks where we are showing the result in terms of some graphs, some or some visualization tools, etc. Embedded systems where we combine microprocessor and microcontrollers with the devices that will be helpful for controlling the various devices in the network. In IoT applications, so we have a lot of applications that we can able to make out of the IoT ecosystem where we can use for agricultural application or from industrial point of view or also from the education point of view. We can develop a lot of applications using this IoT ecosystem. Then we need to add the security mechanism like encryption or firewalls that will be helping to secure the data that we are storing in the cloud. because we have the network. In the network, we have different devices. So when we want to control the security mechanism, when we want to have the security, we need to have the encryption, decryption, and other authentication protocols. Then big data. We know that a lot of information is coming to the internet by using the social media. We have a lot of images, audio, and video. So these are unstructured data that we can use for some useful applications. That is called as the big data analytics. Then AI and ML. We know that artificial intelligence machine learning algorithms can be used for take the decisions and for making the predictive analytics and also for classification tasks. We have some supervised and unsupervised learning algorithms that can be used for prediction and also for classification also. Then blockchain. So by using the blockchain, we can able to give the security for the data and also for make the transaction very secure, and it helps a lot in giving the security for the data. So after discussing the IoT ecosystem, then we go for the structured data and unstructured data. So we have a lot of data. Data is nothing but some information that we get from the different sources. There we have three different types of data: structured data, semi-structured data, unstructured data. Structured data means it's like a rows and columns. We have some structure. So it is very easy to represent the structured data. Suppose I want to store the CA marks of the students, internal assessment marks, where we have the Excel sheet. In that we have some serial number, mark of the different students we can able to store easily in the form of the rows and columns. That is the example for structured data. So we are using some database, SQL database, where we are storing the data in the form of rows and columns. So here we have some example is that customer records, customer names, phone numbers, address, etc. And financial transactions, our daily transactions that we make through the bank applications. Inventory data, like a product availability data, we can able to store in the structured data in the Excel format. Then advantages is very easy to store. You can easily write a query. You can able to get the data. It is very easy to analyze also. We can draw the graph and we can plot the graph. We can do some sorting. We can able to filter the data. Everything we can able to do in the structured data because it is using Excel. The Excel lot of operations can be done. And it has a very high accuracy because it is having a predefined structure. One of the drawback of this structured data is that they have limited flexibility in handling complex unstructured data that requires the predefined schema to store the data. Because most of the data that we see in the internet is unstructured data. The main thing is to handle the unstructured data only because structured data is very easy to handle, but unstructured data is very difficult to handle because it has no predefined structure. That is called as unstructured data. Before going past the unstructured data, I would like to show a table that containing the customer information, just customer ID, first name, last name, and address. So we have row and column information where it is very easy to store the data. We can easily query the data. We can easily filter the data also. We can easily search something also. That is an example for structured data. Unstructured data, the data which is not in a predefined structure, that is called as unstructured data. It has a lot of text, image, audio, or video with some complex information that we cannot able to easily handle or organize. So it has a multimedia file, social media post, email, etc. So they don't have any structure. So it is very difficult to handle this data. For example, email message, social media content, tweets, posts, then videos, audio files, sensor data, some IoT devices, and also web pages. So what is the main advantage of using unstructured data is that can store large, complex, and diverse data types, more flexible and capable of capturing real-world information, useful for text mining, natural language processing, and AI/ML models. But what are the main drawback of unstructured data is that it is very difficult to analyze. It requires the complex tools and algorithms for analyzing the unstructured data because it doesn't have any predefined structure. So we cannot able to easily handle the unstructured data. We need some special algorithms tools and techniques to handle the unstructured data. But remember that 90% of data that we see across the internet is only unstructured data only. So one schematic diagram is being given where you can able to see the difference between structured data and unstructured data. In structured data we have some numbers, date and strings, but in unstructured data we have the image, audio, video, etc. So 20% of data is only structured data, 80% of data is only unstructured data. That means the unstructured data is very important compared to the structured data. But structured data requires less amount of storage space, but unstructured data requires more amount of storage space. So we can display the structured data by using normal table, rows and columns. But in case of unstructured data, we cannot use the normal table, rows and columns. We need a NoSQL database. Some key points are given here to compare the structured data and unstructured data. Format. Structured data is stored in columns and rows. Unstructured data is stored in the form of the image, audio or video. Storage can be done using SQL database, but in unstructured data, the storage can be done using the NoSQL database. So we can use a lot of tools like SQL, BI tools we can use for structured data, but in unstructured data we cannot use the tools for analyzing the data. Then examples, for example, here the customer data, financial records. In unstructured data we have social media posts, multimedia and emails. Usage. So where we can use structured data is we can use for transaction system, like our daily transaction in the bank transactions. We want to know the account balance, what is the deposit money, when is the last day to deposit the money, everything we can able to know if we are using structured data. But in the unstructured data, so we can use only machine learning algorithm, sophisticated algorithms only we can able to use for unstructured data. So we cannot use a normal algorithms. Then we come back data in motion and data in rest. Data in motion means the data which is keep on moving from one location to another location. For example, private networks, public internet channels, cloud, etc. Wireless transmissions. So they have the data in motion. That means data is keep on moving from one place to another place. It is not stagnant. It is keep on moving. Dynamic. That is called as the data in motion. So data which is in motion can be intercepted by malicious actors, leading to unauthorized access or data breach. While data in motion, data may be corrupted for various reasons, including network issues, hardware failures, or human error. We should be very, very careful. We have to do some algorithms, like we have to use the encryption and decryption mechanisms or some other mechanisms, cyber security based mechanisms that will be helping to have the security for the data that we are transmitting over long distances. Then one more thing is also not only security, but one more thing is latency. Time it takes for data to move from one point to another point is very, very important in real-time applications. Suppose you take a real-time application where we need to take the decisions immediately, then we cannot wait for some time. We need to take the action immediately. In such examples, we cannot use the data in motion. That is the main difficulty of data in motion. Data in rest. That means data which is not moving here and there. It is stored in the particular storage device. That is called as a data in rest. That is, for example, database, hard disk, the data which are storing in the hard disk, cloud storage, etc. So this data will be the fixed position. They will not move here and there. So it is very difficult, very easy to handle such data because they are in a particular place only. But what is the main drawback is that unauthorized access can be possible. For example, permission. Suppose we are sharing some data to the friends, we have to be very careful in sharing the permission, like a view permission, a edit permission, etc. So we cannot be able to share the data for unauthorized persons. Should be very careful. So when you are giving the access, we have to properly make sure that It is accessed only by the people who are working in the organization. We are not going for third party access. So we need to take very much strict action for preventing the unauthorized access. Then data masking. So we can use the data masking to hide the specific data within the database. Suppose we have some important data that we cannot able to share with others. We can use the masking concept where we can mask some data. The regular audits. We have to conduct the regular audits and we have to check for the vulnerabilities and also for misconfigurations. So we have to keep on checking the data. That is called as data in rest. So we are comparing the data in rest and data in motion. So data in motion means the data is currently transmitted. Data in rest means data is stored and not currently transmitted. For example, live streaming data, online transactions, that is the data in motion. But data stored in the files, hard disk, database, backups, these are called as data at rest. So we have to follow the encryption mechanism while we are transmitting the data by using the secure socket layer in case of data in motion. In case of data at rest, you need to follow the some backup mechanism. Suppose some person is deleting your data, you have to some backup. So processing. Data in motion involves real-time processing because data is completely keep on moving from one place to another place. So we have to have the real-time processing. But in case of data at rest, we need to go for the batch processing or querying. By reading the queries, we can able to get the data from the database. Batch processing means we are forming a batch. We are getting a group of data that we can able to fetch from the database. Use cases. So we can use the data in motion, for example, in financial transactions and real-time analytics of data. In case of data at rest, we can use only for few applications like data warehousing, backups, and archives. The tools that we can use in data in motion is Apache Kafka, AWS, and other things. But in data in rest, we can go for Hadoop and Amazon and Azure, etc. So this is the comparison of data in motion and data at rest. Suppose we have collected the data is collected, then we should go for analytics of data. That is, we have to get some useful information from the data. So we have to know what is the why it is happening. That is called the descriptive. Why it is happening. Then diagnostic means why it happened. What is the reason? Why the particular thing has happened? Then predictive means what is will happen in the future. Something what will happen in the future. Then prescriptive means something we are taking some control actions before the occurrence of the particular thing. Preventive action. Okay, these are the four different types of data analytics: descriptive, diagnostic, predictive, and prospective. So we can analyze what will happen in the future, what is the data that we are having now. That is called descriptive analytics. Diagnostic means we are going for deep analysis, like why it happened, what is the reason for occurrence, etc. So we can use some machine learning techniques or some big data techniques to do some processing of data, because we have a lot of data like location data, we have the video, audio, some email message, etc. that we can able to handle with the help of the big data techniques. So which I explained in the previous chart, that is the descriptive analytics, diagnostic analytics. Descriptive analytics means we are giving some historical data. By using the historical data, we can able to make some description. That is called as descriptive analytics. Suppose in Amazon I am buying some product. Suppose I can able to see what purchases I have made in the previous month or previous year, etc. Historical data, that is called as the descriptive analytics. So we can have some graph. The graph is showing the revenue of the company in the past 1 year, like that. That is called as the description. prescriptive analytics. Next one is the diagnostic analytics, where we are going deeper into the historical data. We are going to find out the reason for the failure or something like that. Diagnostic means we are going inside the data. We are diagnosing the information. Suppose you go to the doctor, you want to find out whether the person is having the corona or not. So he is going to take your scan and he is going to analyze your data. That is called as the diagnostic analytics. Descriptive means it is going only giving the only description. It is not diagnosing, but diagnosing means it is going deeper into the data. Next one is the predictive analytics, where we are using the historical data. We can able to know what will happen in the future by building the machine learning or deep learning models. Okay, by analyzing our previous watch history in Netflix, we can able to give a recommendation system where we can able to predict what the movies that we will watch in the future based on the previous watch history in Netflix or Amazon Prime. That is called the predictive analytics. But here we need the machine learning or deep learning algorithm like LSTM or CNN that will be helping to have the predictions. Then prescriptive analytics, that means they are giving some recommendation or some actions that will help to achieve the outcomes. Suppose in case if we take a examination point of view, after the exam is over, the class advisor or the staff members, they analyze the result of the student. So based on the analytics, they are giving some recommendations or actions. Suppose for connecting some coaching class or preparing the notes or preparing some key points, etc. or preparing question banks, that will help to achieve the output. That is called the prescriptive analytics. So we are giving some recommendations or strategies to achieve the desired outcomes. Okay. These are the four different types of data analytics. First one is the predictive, prescriptive, then descriptive, diagnostic, etc. Then we have some challenges in handling the data. That is called as the IoT data analytics challenges. Because we have different types of data, not only single type. We have the multimodal data like audio, video, text data. So the data is a different range of data also. Now we have huge collection of data. There is a diversity of data. Scaling means a huge collection of data. GB of data or TB of data. So scaling. Real-time nature, because real-time data is a quick data or keep on changing data. Okay, that we cannot handle the very proper way. So we have to have the specialized algorithm to handle such data. So first we collect the data, then we go for processing of data, then we go for analyzing the data. So we need to do some process, that means pre-processing. We call the data we cannot use it directly. We have to have some remove the unwanted data information. Before giving the data to the machine learning algorithm, we need some trimming, that is called as pre-processing. Then these are the three V's: velocity, volume, variety. So these are called three V's of big data. First is the volume. Volume is how much data you are going to store. The quantity of data. Next one is volume of data. That means variety of data means all different varieties of data like audio, video, text, etc. There is a variety of data. The next one is velocity. Velocity means how speed the data is traveling. Sometimes the data will be a rest condition, sometimes data will be in the moving condition. That is called the data in transit, data in rest, that we discussed in the previous slides. Velocity of data. Sometimes the data is keep on changing. We take the temperature of the place, it will keep on changing from second to second. That is called the velocity of data. But if we take some data that will not change, these are called the three V's of big data: volume, velocity, and the variety. So you should be very careful in dealing with the three V's. For example, if we take the smart city traffic management example, So here we need to have the real-time processing of data because we have a lot of sensors. The sensors are based at different locations in the city. From the sensors, we have to collect the data and we have to monitor the data and store the data in some place, and we have to do some processing of data also. So we can use the edge computing or cloud computing. But in this case, since we are using real-time data, edge computing will be very much suitable because edge computing reduces the latency. It also gives the more efficient processing everything. Cloud we cannot use for real-time data because we have large latency to go for the cloud-based application. We can see there are two images are given, structured data and unstructured data. In structured data, we have different boxes, all are in same color, blue color. That means the data are of same type. But if we take the image of unstructured data, we have different colors of data. One is audio, one is video, one is image, like that. That is unstructured data. But the data that we collect by using sensors, mostly it will be only unstructured data, not a structured data. So we have to carefully observe the unstructured data and we have to convert it to suitable numerical vectors before giving to the machine learning algorithm for classification. We take hospital data. In hospital data, we have a lot of information like audio, video, image. We take an X-ray image, X-ray scan, CT scan, MRI scan, and we have the blood pressure, heart rate, etc. So we have different varieties of data. One is the audio, one is the video, one is the image, etc. That is called as the data variety of data. Sometimes what may happen, the data, some way sensors is malfunctioning of sensor, environmental interferences, network issues, etc. That is called as the main hindrance for data collection. Sometimes the sensor that we are using may not be a good one. It may be a old one. It may be used many number of times. It may not give the proper reading of data. That is called a sensor malfunction. Environmental interference. That means when you are transmitting data through the wireless medium, there is a chance of interference. Network issues. Sometimes you may not get the network in some remote areas. Suppose I want to do a project based on 5G, but in village side, remote areas, we cannot able to get the 5G signal. Next one is the data variety. There is the next one is the industrial IoT. So in industry, we use a lot of sensors to monitor the machine's condition. Suppose there are 1 lakh machines in the company, they cannot go and check the each and every machine whether it's working correctly or not. So we can use a machine learning algorithm. We can use some sensor data. By using the data, we can able to know which machine is under fault. For example, if we take a normal machine, it will have less amount of heat and vibration. But if you have fault machine, you have the vibration is more and the heat is also more. That is, you can able to identify with the help of the sensors. That is called industrial IoT. So we are using IoT devices to monitor the various parameters in industries. So scalability refers to the handling large amount of data. Sometimes, for example, suppose we take today I have 2 GB of data. In the future, I may have to handle the 10 GB of data. That is called a scalability. So we have to take some measure such a way that even the data is keep on changing, the storage capacity is changing, we can able to store the data in some place. So we have to have some infrastructure that can able to store the data in the future purpose also. We take a smart agriculture that we have different parameters like temperature, humidity, moisture, crop health, etc. Where we can use a distributed cloud computing system, we can able to save the memory space. Then we can also make the data very efficient for handling and processing. One more challenging task is the real-time analyzing of data. Real-time means immediate action to be taken. Example, Tesla automatic car, where we need to take the action immediately if the some hindrance is coming before the vehicle. We have to stop the vehicle very much faster so that we can able to avoid the accidents. Such a case is the real-time analytics. Already we discussed is that security and privacy. We need to have a security mechanism for the data that we are using in the cloud computing because we are connecting lot of devices. The devices should have the security mechanism for the devices. So I given some case studies where healthcare provider is using IoT devices because we know in hospitals the patient information is very much personal information that we cannot able to share with the other persons. If we go to the doctor, he will he will not reveal your information to others because he will keep everything as secret information. So we have to have end-to-end encryption. We have to have security protocols also. Then we can use two technology like edge computing or cloud computing based on the application. So if you have less, if you can able to store data, large amount of data, you can use for cloud computing. Edge computing we can use for having less latency, high speed data analytics can be done with the help of the edge based computing. Then one more main problem in IoT devices is that we have different devices. Each device is having some different operating conditions. They have different standards. So we cannot able to come to the conclusion of which device to use, which application. Because there are, suppose assume there are 10 devices, each device is having some separate standard, separate operating procedure, everything. So it is very difficult to integrate all the devices into the single application. So coming to the second part of the IoT lecture, we have the big data. So I have shown some examples where we are generating big data. First is social media data, that is the Flipkart, sorry, Facebook or Twitter, where we have lot of messages, audio, video, everything, etc. Then e-commerce application like Amazon or Flipkart, so where we have the customer data, past history of data, healthcare application, patient information, finance, stock market transactions, telecommunications, card records, contacts, everything, smart cities, IoT sensors, weather forecasting, like the weather condition like pressure, atmospheric temperature, etc. So we have something called as Hadoop ecosystem where we have so Hadoop is an open source framework where we can able to use the big data in a much easier manner. So big data we cannot use the traditional RDBMS for storing the big data. We have to go for the Hadoop ecosystem. So Hadoop has made its place in industries and companies that need to work on large data sets, which are sensitive ones that need efficient handling. For large amount of data, we cannot use the traditional RDBMS for storing such huge information. We need to go for the Hadoop, where we are storing the data in different clusters, several modules we can use. So this is the different modules of Hadoop ecosystem where we have data storage, data processing, data access, and data management. At each level, we have different devices like a zookeeper for data management. For data access, we have big hive, etc. For data processing, we have MapReduce and Yarn, etc. For data storage, we have the HDFS, HBase, etc. Then we have one more thing as Apache Kafka, that is a open source distributed event streaming platform that is developed by Apache Software Foundation. are designed to handle real-time data. So if you want to handle a large amount of data, you can go for the Apache Kafka. Suppose if you take an example scenario where in ride-sharing app, the events like user request for ride, driver location, ride completion, these are called as the events. If you want to store the events, go for Apache Kafka. That is called the event streaming platform. Booking the ticket is one event, giving the feedback is one event, then sharing the location is the event. So when we want to have the different events, we can go for the Apache Kafka, which is nothing but event streaming platform. So we some come back about the throughput. Throughput means the amount of data that can be processed or transferred over a particular period of time. That is called the throughput. So latency means the time delay between when request is made when the system is responding. That is microseconds or milliseconds. So we have something called a NoSQL database. So these databases are very much helpful for storing the unstructured data or semi-structured data. For normal structured data, we can use the SQL database, but for unstructured data, we can use the NoSQL database. So in SQL database, we have something called as the rows and columns. But in NoSQL database, we have the key values as like a dictionary in Python. So we have unique keys with the values or like a graph, etc. that we use in the NoSQL database. What is the role of machine learning? So machine learning can be used in different IoT applications where we have to give the prediction and classification. So if we want to go for real-time data processing, we need to use the machine learning algorithm. Then for building recommendation systems like Netflix or Amazon, where they are giving the recommendation products based on the previous history, that is done with the help of the machine learning models. So we normally go for CNN for the image information and for LSTM for the sequence text data. So we have different applications for IoT, smart agriculture, IoT in disaster management. So I have given the emerging startups in India where they use the IoT devices like a Be Hero. So Aruga AI farming. These are the companies where they do the smart agriculture with IoT devices with machine learning. The next one, IoT disaster management, where we have a company like IRB Smart Flood Alert System. So in North India, we have this flood alert system that is based on IoT devices. So we need to alert the people before the flood is going to come, where we can able to move the people from one location to another location, where we can able to save the lives of millions of people. IoT in wildlife conservation, if we want to track the animal movement, because we know that there are some endangered species, we have to preserve the species animals like white peacock, white tiger, etc. So we can use some devices to track the animal movement. So we have some some collars, the location-based collars. The collars are kept in the neck of the animal. If the animal is moving from one place to another place, we can able to track the location using the GPS. In IoT in aviation and aerospace, the companies like Boeing, Rolls-Royce, they are using the IoT to know the working condition of the engines. We can go for the simulation before going for the real-time flight. We can go for simulation. When the result is very good in simulation, then we can go for the real-time implementation of the engine of the aircraft. Then Reliance Geo is using the RFID tags for smart logistics and air quality management. So then we go to the role of academia. As a faculty of the college, we can able to include the lot of topics in syllabus that will help for the promotion of IoT and applications. For example, IIT Madras, IIT Delhi, IIT Hyderabad, they have the MTech and BTech programs with IoT specialization. NPTEL is also providing a lot of IoT courses. And AICTE is giving the connecting the hackathons like Smart India Hackathon, where we can discuss the IoT project.